Welcome back to question 6 of our falling body problems. This time the question reads, a ball is observed to pass a 1.4 meter tall window going up and later going down. The total observation time is 0.40 seconds. That is 0.20 seconds going up and 0.20 seconds going down. How high does the ball rise above the window? Let's start with an illustration. So we have a window that is 1.4 meters tall, and the ball goes up, and then it goes directly down. Now, before I show you the solution, there are several ways to solve this. So I'll show you my version, but feel free to diversify and try it your own way. The first thing I want to calculate is the average velocity. We're told that the total observation time is 40 seconds, and the window is 1.4 meters. Remember, velocity is a measure of distance over time. So the distance here is 1.4 meters, and the time is 0.2. So that's the time that it takes the ball to traverse the window. If I calculate this, I should end up with the velocity midway in the distance of this window. So I should get the velocity when the ball is 0.7 meters from the bottom of the window. Calculating this, you should end up with 7.0 meters per second as your velocity. Now that we have this value, we can start to write down everything we know. So if we start at the midway point of this window, the initial velocity is 7.0 meters per second. The initial height, which I'll denote as x sub 0, is equal to 0 meters. We're actually looking for the ball, how high it rises. So I'll represent the final height as simply x, and I'll put a question mark there. The acceleration due to gravity will be negative 9.8 because the acceleration here is decelerating the speed of this ball. And because it's deceleration, I'll represent the gravity as negative 9.8 meters per second squared. Because remember, gravity pulls you downwards. We actually have everything we need to find out x. If you look at this formula right here, we can start to plug in everything we know. For example, this represents the final velocity. I'm going to assume that once the ball reaches its peak, where it's no longer going up, the velocity there is equal to 0. So I have 0 squared is equal to the initial velocity of 7.0 raised to the power of 2 plus 2 times negative 9.8. The final height is what we're looking for, and the initial height is 0. So let's go ahead and calculate this. We have 0 is equal to 49. 7 to the power of 2 is 49. Multiplying these out, let's use our calculator, 2 bracket negative 9.8. That gives us a value of negative 19.6. So negative 19.6. And this part simplifies to x. Let's solve for x. Let's bring that 49 over. We have negative 49 is equal to negative 19.6 x. Dividing both sides by negative 19.6. This and that cancel out, and we should end up with an x value that is positive. So negative 49 divided by the answer we just got, and that is 2.5 meters. Let's interpret this value. If we go back to the illustration, 2.5 is the distance from this point to that point. So that right there is 2.5 meters high. To get the distance from here to here, you simply subtract 2.5 minus 0.7, that distance, to get 1.8 meters. 1.8 meters above the top of the window. And there you have it. Our sixth and final question on the falling body problems.